Hi friends, this is PH1502L Laboratory Experiments by Dr. M.R. Gadhvi. Today's experiment we will be focusing on vibration magnetometer. Our aim is over here in this experiment is to calculate the ratio of magnetic moments M1 upon M2 using a vibration magnetometer. The apparatus we will be taking, that is vibration magnetometer itself, two bar magnets, weighing box, compass, etc. The procedure I will be showing you through a video, so it's not to worry. Vibration magnetometer looks like this. It has a wooden box having glass panels. On top of the box there is a one cylinder through which a silk thread is passing. The another end is tied with the hanger. The second end of the string will be tied with a nail kind of a setup, which is controlled by the two screw for the further maintenance of the silk thread and so on. There is a two leveling screw are there. So first of all, one has to set the vibration magnetometer by putting a levelometer, but once it's set, it's always set, so not to check every time. Then by keeping a compass on top of the panel, you have to adjust your vibration magnetometer exactly parallel to the earth horizontal component. माने आपको क्या करना है, यहाँ पे कंपास रखिए, मैग्नेट यहाँ पे नहीं रखना है, और आपको चेक करना है कि वेदर द एंटायर कंपास इज पैरेलल with the magnetometer and the earth horizontal imaginary component, माने डायरेक्शन ऑफ अ नॉर्थ पोल साउथ पोल डायरेक्शन ऑफ द मैग्नेटिक नीडल. ये फिर से मैग्नेटिक नीडल और ये वाइब्रेशन मैग्नेटोमीटर. जहाँ तक मैं आपको बता दूँ, यह मिरर में एक लाइन ड्रॉ की होगी. सो मैग्नेटिक नीडल और लाइन को दोनों पैरेलली सेट करना है, एंड दैट वुड बी द setting for the vibration magnetometer before starting up the experiment. Once you start the experiment, there is a 4 part of the experiment. Part 1 में आप दो मैग्नेट के सिंगल पोल सेटिंग माने सिंगल मैग्नेट्स लेके आप ये यूज़ करोगे वाइब्रेशन मैग्नेटोमीटर. माने बार मैग्नेट 1 रखोगे, मैग्नेट 1, उसके बाद बार मैग्नेट 2 रखोगे, और दूसरा पार्ट में आप अनलाइक पोल्स माने दोनों मैग्नेट्स M1 और M2 जो मैग्नेट थे वो दोनों के अनलाइक पोल माने एक का नॉर्थ और दूसरे का साउथ, इस तरह से हम यहाँ पे रखें. लेट अस चेक इट द वीडियो सो पिक्चर गेट मोर क्लियर. As shown in this video, the north pole shown by a dot or an N type of character. The direction of earth horizontal component is this. Then we will be keeping the magnet parallel to the vibration magnetometer as well as parallel to the earth horizontal component, which we can identify by the compass. Gently keep it in a hanger so it will not oscillate or wobbling. Slowly close the shutter, and thereafter wait for a while to get stable. Take the another magnet, bring it close to the hanger. It start oscillating because of the action of like pole or dislike pole, and you will having a smooth oscillation. Once you achieve the smooth oscillation, with reference to the mirror black line, you have to note down the reading. Reading will be easier to take it from the top, and that way you can start your stopwatch and note down the 20 oscillations time period. Once you finish this one magnet reading, go with the magnet 2. Replace the magnet 1 by the magnet 2 and repeat the experiment. So this is about the single magnet या तो single pole. Thereafter you have to, in the part 2, we will be taking the unlike pole. In case of an unlike pole, we will be taking both the magnets, that is M1 and M2 together, and that's why it become the unlike poles. माने एक का नॉर्थ पोल दूसरे के साउथ पोल के ऊपर रखेंगे. We will be looking in this video number 2. And let's have this one. So this is magnet 1 north pole, this is magnet 2 north pole south pole revert kiya, and now I am keeping unlike pole together. Since they are unlike poles, so they will stick together permanently, not an issue. In both when they are attracted to each other, so दोनों मैग्नेट को एक साथ हैंगर में रख देना है. Slowly close the shutter from the top of the window. Again you need to take the reading for a 20 oscillations. The question arises how I will allow to oscillate them. You can again open the shutter and gently touch a pair of magnets, and therefore it start oscillating. Again wait for a certain while, so it gets stable oscillation, and once it start giving a stable oscillation, with reference to the mirror line we will be noting out the 20 oscillations time period. जो तीसरा पार्ट है that is rather the fourth part. पहला पार्ट था सिंगल पोल और सिंगल मैग्नेट फॉर M1. दूसरा पार्ट था सिंगल मैग्नेट again, but magnet is different, so M2. The third part is a unlike poles, माने M1 और M2 साथ में लेकिन unlike pole की सिचुएशन में. और नेक्स्ट सिचुएशन जो हम देखने जा रहे हैं वो है like pole situations. So that is like pole situation. The like pole, as it is given the idea, like pole doesn't stay together, so you need to tie those one with a string, क्योंकि like poles are repel to each other, तो हैंगर में साथ में नहीं जा सकते. तो पहले क्या करना है, आपको ये जो डॉट की सिचुएशन से आपको नॉर्थ पोल का इंडिकेशन मिल रहा है, तो एक का नॉर्थ पोल, इसके ऊपर दूसरा मैग्नेट M2 का भी नॉर्थ पोल रहेगा, एंड देन यू हैव टू टाई अप, एंड अगेन नॉर्थ पोल विल बी रिमेन इन द डायरेक्शन ऑफ अ earth horizontal magnetic component. Let us look at the video one by one and try to understand. Look at here the north pole of a red magnet. I am keeping on exactly north pole of the black magnet, and this will not remain together, so I need to tie up with a string, right? Okay, how I am going to tie up and how I am going to take the reading, let's look at with the another slide. I'm sorry, it's missed, so let me check, rewind for you. So now I tie up with the string, and then again the way of methodology is same. The north pole remain in the north direction, and I'm keeping in a hanger very gently, very smoothly, so it should not oscillate. Perhaps I missed to show you that how exactly a pair magnet can take the direction of oscillation for the hanger. So you can touch gently with a pencil or a finger. Once it achieves the stable position, let's say I'm taking pencil, gently touch it so it start oscillating, and once it oscillate, I will slowly close the shutter so I can avoid the wind and so on, and thereafter I will be taking a reading with the help of stopwatch from the top window, and that's how I will be taking 20 time period oscillations. So this way you have in all 4 set of the observations. Number 1, single magnet M1 20 oscillations 2 times. Thereafter single magnet M2 20 oscillations 2 times. Thereafter unlike pole, माने एक मैग्नेट का नॉर्थ पोल, सेकेंड मैग्नेट का साउथ पोल, और that way you have to take it 2 times 20 oscillations time period for that setup. And finally is the like pole, where you will be taking the north pole setup of a magnet M1 and M2, keep them together along with the earth horizontal component and take the 20 oscillations 2 times. The equations we will be using to find it out the magnetic moment inertia, that is a moment inertia, ગુજરાતીમાં આપણે એને જડત્વની ચાક માત્રા કહીએ છીએ. So I, so that I will be measuring by mass divided by 12 into bracket square of length minus square of breadth. So you will be provide a vernier calipers. With the help of length and breadth, we will be taking its length square minus breadth square multiply by mass divided by the 12. This is a equation to find it out. This one, length and breadth you will be measuring in general we are keeping the MKS unit, so we will be measuring them in a meter, don't forget it. Okay, by chance you take it in centimeter, then lastly you can convert into the centimeters, not an issue, I mean meter. Thereafter the periodic time. How shall I find it out the periodic time? Ideally you know that it is the number of oscillations or time taken by the number of oscillation, let us say 10 oscillations divided by the number of oscillations. So 10 oscillation का टाइम मैंने नोट किया, डिवाइड बाय 10 किया तो 1 oscillations का टाइम पीरियड मिल गया, एंड दैट इज व्हाट द नोन एज अ पीरियोडिक टाइम. बट सिंस इट इज अ मैग्नेट, since it is having a mass, and therefore it is needed to take it a incorporation of this moment of inertia and the magnetic moments of it, the magnet itself and the field, that is H. At presently the H which is available, that is earth horizontal magnetic component. अगर वाइवा में पूछे कि अगर ये टाइम पीरियड मुझे ढूंढना है और ये H आप क्या लोगे, so that would be the earth horizontal magnetic field. So that is there. So anyway, once you have a T1 and T2, that is respectively for the magnet 1 and magnet 2, only the variation is M1 and M2 is the respective magnetic moments of the magnet A and B, or the magnet 1 and 2. And now if I will take the ratio of M1 and M2 by making the equation, my equation will be reduced to the factor something like M1 upon M2 into I1 upon I2 T2 square upon T1 square. So naturally the periodic time, as I told you, number of time taken by the number of oscillation divided by number of oscillations. So you can have the T, you having a I from the equation number 3, and therefore it's easy to find it out. So in nutshell, I can eliminate the effect of the M over here by taking the the H over here by taking the ratio of it. And same way, once I have the combination of it, so using the logic of equation 2, the like poles and dislike poles, or the like poles and unlike poles equation will be converted exactly in the I1 plus I2 in both the case, but in like poles the magnetic moments will be add up, and in unlike poles the magnetic moment will be subtracted. And I will there is a condition that M1 should be greater than this one. तो दो मैग्नेट में से एक मैग्नेट हेवियर होगा तो नेचुरली उसकी मैग्नेटिक मोमेंट पावरफुल होगा. सो यू डिफाइन द हेवियर मैग्नेट, जिसका मास ज़्यादा है, जिसका मास ज़्यादा होगा, जैसे कि मोमेंट ऑफ इनर्शिया, या तो आप ये भी समझ लो कि जो मैग्नेट का मास ज़्यादा है या तो जिसका आई ज़्यादा है, दैट वुड बी यू कंसिडर एज अ stronger magnet M1. That is, so M1 will be, in our case it's a M1 is larger than the M2. Okay, so with the help of equation T3 and T4, if I will take a ratio of this equation 6 and 7, my equation will be reduced to the notation of M1 minus M2 upon M1 plus M2. And therefore the same way, basically I am interested, as I mentioned in my aim, I am interested in the M1 upon M2. So I need to convert this relation in M1 upon M2. So I do the summation on top, do the summation at bottom, and that way I can having the process of mathematical will give me the equation reduced to M1 upon M2 is equal to T3 square plus T4 square upon T4 square minus T3 square. So with this is the equation setup, I can having a calculation. As I told you, there will be a weighing box, so you can measure the mass of a magnet M1, and it is, let us say, coming 468. For M2 you are getting a 40. दोनों की मैंने लेंथ मेजर कर ली, दोनों की मैंने ब्रेथ मेजर कर ली. एज आई टोल्ड, आई एम मेजरिंग विद ईदर अ गुड रूलर और this length, this what is called vernier calipers. And with the equation what I have seen previously, the equation number 3, m by 12 L square minus B square. With this equation I am able to get the जड़त्वनी चाक मात्रा or I, that is a inertia for a given body, that is I1 and I2. If you look at here, I1 is much powerful, so M1 is greater than the M2. Okay, now how I will be taking reading? पहली वीडियो में दिखाया था single pole or single magnet, so that is M1, that is a case 1, and case 2, M1 individually, M2 individually. I am taking the data and I am getting the time period for each one. It is getting almost similar, and to find it out the time period, I will be taking a time taken by the 10 oscillations. So 67 divided by 10, so it is a 6.7. It is 66 divided by 10, so it makes 6.6. Now the like poles, that means the last video where you have tie up the string, दोनों को north pole साथ में, so उसका 58 सेकंड मिला. तो 58 डिवाइड बाई 10, सो इट बिकम 5.8. अनलाइक पोल माने एक का नॉर्थ पोल और दूसरे का साउथ पोल, वीडियो नंबर 2, और वहाँ पे डोरी स्ट्रिंग या टाई अप करने की ज़रूरत नहीं, बिकॉज इट्स अनलाइक पोल, एंड देयरफॉर इट बिकम 117 and it become 11.7 seconds. With this I can having a capital T1, capital T2, capital T3, capital T4. Using this I will be using equation 5. I will be having a ratio of equation magnetic moments M1 upon M2 using the first individual case, that is observation table number 1 and 2. मेरे पास ratio of magnetic moment ये equation के मुताबिक इनर्शिया को लेके और रेशियो ऑफ T1 स्क्वायर T2 स्क्वायर को लेके मिल सकता है. दूसरा एक लाइक और अनलाइक पोल का साथ में लेके मैं T और T3 और T3 और T4 का कैलकुलेशन चेक करके यूजिंग इक्वेशन नंबर 8 I can again having the ratio of M1 upon M2. नेचुरली M1 upon M2 रेशियो मेरा दोनों में सेम आना चाहिए. अगर मैं इंडिविजुअल ले लूँ या तो साथ में लूँ. मैग्नेटिक मोमेंट इज़ अ इनहेरेंट प्रॉपर्टी ऑफ अ मैग्नेट. बेसिकली कोई भी मटेरियल ले लो आप, राइट, एटम ले लो, वायर का सर्कल ले लो, piece of a magnetic material ले लो, there is always magnetic moment. So basically it is a product of the magnetic strength, that is the distance between dipole to the distance between the two poles, and that is how the magnetic moments will be understood. Okay, and this is a first calculation. We are getting a 1.09 using a individual reading or a single reading M1 upon M2, where the inertia we are taking a support and we are taking the support of T1 square plus T2 square. So the periodic time of the first case, periodic time of the second case. The other way of a calculation without taking the inertia, we are taking this लाइक एंड अनलाइक पोल, माने दोनों मैग्नेट साथ वाला केस, एक में लाइक पोल वाला सेटिंग, दूसरे में अनलाइक वाला सेटिंग. सो यू हैविंग अ T3 स्क्वायर एंड T4 स्क्वायर. ऑन दिस बेसिस यू हैविंग अ 1.6. अगर ध्यान से देखा जाए तो इसमें 0.6 का वेरिएशन है, तो थोड़ी एरर है. एरर कुड बी पॉसिबल बिकॉज ऑफ योर पीरियोडिक टाइम, बिकॉज पीरियोडिक टाइम स्क्वायर फंक्शन में आगे बढ़ रहा है. सो वाइल यू आर टेकिंग द ऑब्जर्वेशन टेबल, you should be very conscious about your switching on and switching off of your stopwatch, and therefore it is needed to have the clarity about this one, because errors will be in the square function will be enhanced. So a small variation in time period will make it the enlarged effect. So just read about the what is magnetic moment, what do you mean by vibration magnetometer. uh, these are the fundamental questions. What is a north pole, what is a south pole, how I can understand a magnet, what is the difference between a magnetic material and non-magnetic material. These are the things you should aware. And all the best. Stay home, stay safe. Thank you so much.